As I mentioned, you know, uh, we have this. We saw the different PT threads. So basically, threads are very lightweight. Threads are very easy to use. Threads can be easily created. Threads can easily be formed from a parent to a child process. All these things are possible. So they are all lightweight and they are very advantageous, so as to speak. So we also saw the PT this video on that. Now what we will do today is we have some while if you recall when we were doing operating systems, we talked about IPC or inter-process communication. So I told you that processes on the other hand are not very lightweight. They are a little they need a lot of memory swapping. They are not little heavyweight kind of thing, and there is a lot of interaction. There are processes need to communicate with each other, and we use what is known as IPC or inter-process communication for the same. And this IPC has to be done through different methods. Message passing interface you would have seen, sockets you have seen in the operating system course. So for distributed computing, primarily we use two types of IPC or inter-process communication, namely remote procedure call and remote method invocation. Actually, we have seen these things in some level of detail in the OS course. The RPC is how do you get a procedure call where you are able to target a kind of a process and have a one-to-one like a socket or a kind of a channel between two different processes. That is the process of an RPC or a remote procedure call. So RMI or remote method invocation is also very similar to that. There you're invoking a method whereby the sender process and the receiver process are able to communicate and have a dialogue with each other. So I will start a short video lecture on RPC, and then we'll go to our this thing.
Hi students, welcome back. Let's continue with our subject distributed system. The next topic in this.
Are you able to hear the video?
Yes, sir.
Yeah.
Subject is RMI. RMI means remote method invocation. So whenever we are discussing about remote means you have to think that it is a server side language, means we are dealing with the client and the server. So now let's see what is this RMI is. The remote method invocation is an application program interface that provides a mechanism to create distributed applications in Java. So by seeing this, what you understand, the RMI is related to the Java application. The first thing is it is related to the Java. And one more thing here is RMI is an application program interface. It is acting as an interface. So it is acting as this remote method invocation is acts as an interface between the client and the server. So this interface provides a mechanism. What type of mechanism it is providing? It is providing a mechanism to create distributed applications in Java. So the RMI is an application program interface. It is used to create a distributed applications, a distributed environment in Java. So if you want to work a distributed environment in Java, you need to use this RMI. That is a remote method invocation. It allows an object to invoke methods on an object running in another Java virtual machine. So the main use of this RMI is it is going to allow one object. Thus RMI allows an object to invoke methods. Okay, so that object is going to invoke a methods on an object running in another machine. Means one is the client is there and there is server is there. So this RMI is allowing the object to invoke a method on an object running in another virtual machine. So here one Java virtual machine is there in the client side, another Java virtual machine is there. So means you have to think this RMI is remote method invocation is acting as an interface between the client and the servers, and it is providing a mechanism to create distributed applications in Java. The RMI provides remote communication between the applications using two objects, stub and skeleton. So these two are the names, you have to remember that, the stub and the skeleton. The stub is present at the client side, and whereas the skeleton is available at the server side. So these are the two objects that we are using while we are working on this RMI. The RMI provides a remote communication. So this remote method invocation is providing a remote communication between the applications, means between two applications, between the client and server, using these two objects, stub and the skeleton. So actually the RMI system layer consisting of 3 layers. The total RMI system is consisting of 3 layers in its architecture. That is a stub or skeleton layer, means is the first layer, and the next is a remote reference layer, RRL, and another is the transport layer. Means the complete architecture of RMI is divided into 3 layers. So this is one is a skeleton, stub and the skeleton layer, and another is the remote reference layer, and another is a transport layer. So total it is divided into 3 layers. So RMI architecture is divided into 3 layers: stub or skeleton, remote reference, and the transport. So just remember that. So here this is one machine, another machine. Each machine, let's take this is a machine A and another is a machine B. Let's call A is a client and B is the server. Okay. So each machine is having one Java virtual machine, JVM. So each machine is handling one Java virtual machine. So in the client side, you are having the client objects, and the server side, server objects are there. So now the client side, client object is handling the object stub. Okay, object S, let's take object S of stub. And this stub is interacting with the remote reference layer. And from remote reference layer, a transport layer will be there, which is used for communication. So we are using the TCP connection to transfer the data from machine A to the machine B. So again here the transport layer and the remote reference layer. From this here the object S skeleton. So here the objects or deals with the stubs, and here if you are dealing with the objects in the server side, you have to represent it as a skeleton. If you are dealing with the objects in the client side, you have to represent it as a stub. So the skeleton and the server objects. So after the operation performs, it again sends back the message to the client object. So this is exactly the remote method invocation. So the remote method invocations uses it. It is a 3-layer architecture, which has the first layer is stub or skeleton layer, and the remote reference layer, and the third layer is a transport layer. Okay, so in the next video, I'll explain what exactly the stub and the skeleton layer is and how these RMI will be implemented. Thank you.
So basically this RMI is a server client kind of interaction between two distributed systems or two parallel systems, the way to communicate. Now let us see the what is that, the RPC or the remote procedure call.
In this lecture, we'll be
Are you able to hear the video?
Yes, sir.
studying about remote procedure calls. In the previous lecture, we have been studying about inter-process communications, and we have seen how inter-process communications takes place using the shared memory systems and also using the message passing systems. And we have also studied about sockets, and we saw how sockets help in establishing communication between processes. So till now, the inter-process communications that we have studied about were mostly based on local process communications. That means we were seeing how processes that resides in the same system communicates with each other. Now, remote procedure calls come into play when we want processes that are residing in different systems connected over a network wants to communicate with each other. So think of a scenario where one process that is residing in a system wants to communicate to another process which is residing physically in another system, and these two systems are connected via a network. So in this kind of a scenario, we need to use remote procedure calls. And remote procedure calls will help us in communication between processes that are residing in different systems connected over a network. So remote procedure call, or RPC, is a protocol that one program can use to request a service from a program located in another computer on a network without having to understand the network's details. So RPC is a protocol that helps one program to request a service from another program located in another computer on a network. And it does so in such a way that the processes that are communicating does not need to understand the network's details. So the network's details does not have to be understood by the processes that are communicating. So RPC takes care of this. Now this RPC is similar in many respects to the IPC mechanism. So we have studied about IPC, which stands for inter-process communication. So RPC is similar to IPC in many ways. However, because we are dealing with an environment in which the processes are executing on separate systems, we must use a message-based communication scheme to provide remote service. So though RPC is similar to IPC in
வீர சேதுபதி ராஜாவோட கற்பனையும் யோசனையும் தான் இந்த அரண்மனைக்கு அழகு. எட்டு கட்டிட கலைஞர்களை வச்சு அரண்மனையோட 8 பகுதிகளை தனித்தனியா வடிவமைச்சார். இந்த அரண்மனை அவருக்கு மனைவியாக போற ஆனபெல்காக பார்த்து பார்த்து கட்டினார்.
நான் அவங்க மேலே வச்சிருக்க அன்பை வெளிக்காட்டுறதுக்காக நான் கொடுத்த சின்ன அன்பு பரிசு தான் இது. அதனால இதை கொடுக்குற உரிமை கூட எனக்கு கிடையாது.
அதே மாதிரி அரண்மனை கட்டினா அதுக்கு பேர் நகல். ஆனா அசல் அது. எனக்கு அசல் தான் வேணும்.
நீ இந்த வீட்ல பேய் இருக்குன்னு சொல்ற, நான் இந்த வீட்ல பேயாவே இருக்கலாம்னு சொல்றேன். யார் நீங்க?
பார்த்தா தெரியல, எல்லாம் ஹாலிவுட் ஆர்டிஸ்டுங்க. நம்ம எல்லாருமே இந்த அரண்மனையை விட்டு வெளியே போனோம்னா அந்த பொண்ணால மட்டும்தான் முடியும். நம்ம பேய்ன்றது அவங்களுக்கு எப்பவுமே தெரியக்கூடாது.
இன்னைக்கு நைட் எல்லாத்தையும் அடிக்கிறோம், இங்க இருந்து கிளம்புறோம்.
நீதான் பேயா?
என்ன பண்ற? சொம்பு கீழே விழுந்தா தான் நம்ம பயப்படுவான். அதான் பாஞ்சு பிடிச்சிட்டேன். நான் சொன்ன கதையில உங்களுக்கு எல்லாம் ஞாபகம் வந்துச்சா? நான் யாருன்னு தெரியுதா? என்ன ஞாபகம் இருக்கா?
அண்ணி மூஞ்சிவாய.
நான் என்ன சொன்னாலும் கேட்க மாட்டீங்களாடா நீங்க? நீங்கெல்லாம் இங்கே கடந்து சாவுங்கடா. நம்ம தான் ஏற்கனவே செத்து போயிட்டோமே.
புதுசா கதை சொல்லாத.
புதுசா எவமா கதை சொல்றான்? பழைய கதையை தான் அப்படியே உல்டா பண்ணி பண்றானுங்க. என்ன பண்றது?
What if, as a data science aspirant, you could first get a top job in data science and then train to be a data scientist? I'm here to tell you about our Data Science Leaders program that lets you do exactly that. As a candidate to our Data Science Leaders program, your application will be evaluated by an eminent jury, and the best candidates will be offered absolute cutting-edge jobs in data science and AI at industry-leading salaries. Then you will train to be a data scientist on a full scholarship with professors from Harvard University and UCLA. Once you're done training, you will join our crack team of data science and AI professionals to work on state-of-the-art projects with our clients worldwide. So who can apply? Well, you need to have a STEM background, And you can be either a student in your final year of college or a working professional. If you're committed to being a data scientist at the top of your craft, then we invite your application.
RPC in many ways. The difference is that since in RPC we are dealing with an environment in which processes are executed on separate systems, we need to use a message-based communication scheme. So if you remember about the two communication schemes that we have studied about shared memory system and we have studied about message passing system. So in shared memory system, what happens is when the processes wants to communicate with each other, there is a region of shared memory that they have. And the process that wants to communicate just writes whatever it wants to communicate on the shared region, and the other process just reads from that shared region. But in case of RPC, we are dealing with processes that are residing in two different systems that are connected via a network. So in this kind of a system, it may not be possible to have a shared region of memory. So that shared memory system may not be possible. So we have to use the other kind of communication scheme that we have studied, which is the message passing system. So in RPC, we will be using a message-based communication scheme. So moving on, let us see what are the other differences that RPC has as compared to IPC. So in contrast to the IPC facility, the messages exchanged in RPC communications are well structured and are thus no longer just packets of data. So in case of IPC, whenever we use the message passing systems, those messages were just packets of data and nothing else. So if you remember when we studied about message passing system, the process that wants to send the message just sends that message as a packet to the kernel, and from the kernel it goes to the process to which that message was intended to. So messages were just packets of data. But in case of RPC, it is not just happening in a single system. It has to travel between one system to the other system. So we cannot just keep our messages as simple packets of data, but they have to be well structured because they have to travel over a network. So each message is addressed to an RPC daemon listening to a port on the remote system. And each contains an identifier of the function to execute and the parameters to pass to that function. So in case of RPC, whenever the message passing takes place, that means whenever one process wants to communicate to another process residing in another system, the message is sent in such a way that the message is addressed to a RPC daemon, which is listening to a port on the remote system. So by daemon, we mean that a program which is always listening or which is always on and which is always listening and is waiting to get some input. And based on that, it will work. So this RPC daemon is always listening to a port on the remote system, waiting for some incoming requests. So we have also studied about the concept of port in the lecture where we discuss about sockets. So if you have not seen that, I request you to kindly watch that lecture where we have discussed about ports and how ports are assigned to different processes. So as we were saying, in case of RPC, when the message is sent, it is addressed to the RPC daemon, which is listening to the port on the remote system. And each of the message that is sent, it contains an identifier of the function to execute and the parameters to pass to that function. Now we are using the term function here. So what is a function? So when we study programming, we know what are functions. So function is a piece of code that is written which performs a specific task. So what are the requirements that we need in a function? The function needs parameters. So based on the parameters, the operation is performed on that parameters and something is returned. So in case of RPC, think of this function as a service which is going to be requested by one process from the other process. So there is a process residing in a system and this process wants a service which is provided by another process residing in another system. So think of that service as a function. So what do? We have to pass the parameters of the function and we have to call the function, and then the function will be executed. So in the same way, in this RPC, we have to pass the identifier of the function, which may be like a function name, and then the parameters that we have to pass to the function. Then after that, what happens? The function is then executed as requested and any output is sent back to the requester in a separate message. So let's take the example of a simple function in programming again. What happens when we call a function? When we call a function, we pass the parameters, and when the function is called, the function gets executed, and after execution, if there are anything to be returned, that will be returned. And where will it be returned? It will be returned to the place where the function was called. So in case of our RPC, who is the one who called the function or the service? It is the first process or the client. So after the function is executed,
Sir, the audio isn't clear, so I think it's on mute.
Okay, fine. Anyway, I have sent the audio, the video lecture to you. So please, you can go through it when at leisurely. So basically speaking, the two major mechanisms for the distributed systems and parallel systems are generally this RPC or remote procedure call and remote method invocation. So this is the what I wanted to cover today. We'll close the classes for the time being. We'll take a pause now. So as I mentioned, for the midterm, which your exam is on 30th, what is the time of the exam? 30th, 1:30 to 2:30 p.m. You have to, it's like a take home assignment come exam. I have already told you the questions. One question is the Riccati and Agarwala algorithm, and the second question is the Maekawa's algorithm. So you be ready with the program, the code, the execution, the screenshot of the execution, the logic and everything. Keep it ready with you. So your submission for both the questions are there. So you can you have to have the code, the screenshot, the execution, the logic, flow chart or anything that accompanies that thing to make it very clear. So this will be the question. It's a take home midterm. So I'm giving you 3 weeks exactly for preparing, and I will do some flag check. So you have to do it on your own. So I will do some, I'll put it to this, turn it in and check if there is any similarity index also. So that's the plan. So we'll take a pause with the classes. As far as the Viva is concerned, the Viva I told you will be primarily distributed systems and a little part of the first part of the parallel systems, the fundamentals of parallel systems. And the scheduling I will connect with Pragya and fix the plan as per your convenience. We can plan it. So that's all from our friend. Next week I'll put attendance for all of you. I'll put present for everybody, and you can WhatsApp me or message me if you have any queries or questions and so on. Okay. So we'll meet later. We'll take a pause. Stay safe, and we'll meet during the Viva unless there is no other requirement. I have already put the slides. Everything is there on the AUMS area. So it's a very somehow the syllabus is very small. So I don't know who has designed this syllabus, but the content is actually very little. But you know, I thought you can use the remaining time to focus on other subjects. Okay, have a nice Vinayaka Chaturthi. Have a nice holiday. Have a nice weekend. Stay safe, and we'll keep in touch. Bye.